Why?
Because they're both ways to put in, and both ways actually have, it's the idea of, therefore,
We do have a lot more today than we did. Alright, so, unit circle. Alright, so I'm going to show you how the unit circle is made. So, the unit circle is a circle at the origin that has a radius of 1. So, 4 of the points on the unit circle you can know just because you know how to graph points. So, whenever you look at the unit circle, the length of this radius is 1. So the coordinates of that point right there are 1, 0. Right? Just like graphing, we're graphing the point 1, 0. We go over 1, up 0. There's the point. Right? And then so this point is up 1 over 0. So this is 0. I'm sorry. Yeah. Over 0, up 1. This point here is negative 1, 0. And this point here is 0, negative 1. So those 4 points you just figure out because it's like graphing the points. So the first one we're going to look at here is we're going to look at finding the coordinates of this point right here where we have a 30-degree angle. So the radius of this circle is 1. So that means that length right there is 1. So if I made myself a right triangle right here, then the length of this bottom side right here of that triangle, that is my x-coordinate. And the length of this side right here, that is my y-coordinate. Because my x-coordinate tells me how far I go to the right, and my y-coordinate tells me how far I go up. So this triangle right here is a 30, 60, 90 triangle. So if my hypotenuse is 1, then Sadie, what would my shorter leg, the y-coordinate here, be? What do we have to do when we go from that hypotenuse back to the short leg? That one's for 45, 45, 90s. Do you remember, Jacqueline? We would divide by 2. Okay, so with that 30, 60, 90, if you know the short leg, then the hypotenuse is twice the short leg. The long leg is that times the square root of 3. So if you have the hypotenuse, you got to divide by 2 to get back to the short leg. So that y right there would be 1/2. So the y coordinate is 1/2. And then Spencer, what do we have to do to get the x? So what do we have to do to get that longer leg of that 30, 60, 90 triangle? Times by the square root of 3. So if I'm doing 1/2 times the square root of 3, that's like square root of 3 over 1. And so that's going to give me square root of 3 over 2. So I get that square root of 3 over 2. Alright, so let me show you why that is helpful. If I want to know sine of 30 degrees, okay, so sine of 30 degrees, you guys probably, whenever you learn trig, you might have learned some old hippie called a high tripping on acid. You might have learned SOHCAHTOA. You might have learned, I sometimes teach Oscar has a hairy old arm. But whenever you do trig, sine is the opposite over the hypotenuse. Right? So if I'm doing sine of 30 degrees, the opposite side of this triangle would be 1/2. And the hypotenuse would be 1. Well, 1/2 by 1 is just 1/2. So sine of 30 degrees would equal 1/2. So let's see, we'll write it over here. So the y coordinate on the unit circle, that gives you the sine of whatever angle you have. I'm going to use a theta here for the angle. So let's put a box around that. So the y coordinate gives you sine. So if I want to know sine of 30 degrees, I could just say, well, sine of 30 degrees, look on the circle, y coordinate is 1/2. I realize you also have calculators that will tell you that same thing if you type it in. But unit circle was, of course, much more necessary to know before calculators existed, because before calculators existed, which is really not even all that long ago, 50, 60 years ago, schools did not have calculators in them. Whenever you did not have calculators, you had to know the unit circle because you couldn't figure out sine of 30 degrees any other way. Now, of course, we have a calculator, and we're still going to use our calculator a lot. But the unit circle still has some value, and we still teach it because it shows us the periodic nature, the repetitive nature of any type of sine, cosine, tangent graphs. Because as you go around the circle, it's going to go over and over and over. So there's some logical things that we gather from it. We don't necessarily have to know it because our calculators won't do it, but we do have to know it for some logical reasons. The x-coordinate, we could do something similar over here. For the x-coordinate, if I wanted to know cosine of 30 degrees, cosine is adjacent over hypotenuse, which in this case would be square root of 3 over 2 over 1. So cosine of 30 degrees is square root of 3 over 2. So if we want to know cosine, we can just look at the x-coordinate. So the x-coordinate is cosine of theta. And so I'm going to go ahead and give you, I've got a blank unit circle here. And I made it a different color because we use this quite a bit. There's several different things that we do so you can find it easily. So on that unit circle, we can go ahead, you could put in those 4 points that I put on here, and that first angle that you see there, it's not marked. You could mark it 30 degrees, and then you could fill in the 1/2 that's where it's got. Add that there. Let's see. Let me open up my. Okay, so on that unit circle, we know this point is 1. One, 0, this is 0, 1, this is -1, 0, and down here we've got 0, -1. This right here, I'm going to go ahead and put 0 degrees. This angle right here, I'm going to put 30 degrees, and we just found that this one is square root of 3 over 2 and 1/2. Okay. Questions? All right, let's keep going on filling this in. Yes? Yes, it would. Like this one right here. You're getting a little ahead of me there, though, Elena. But we are going to do that. You're correct. Okay, so let's look at the other points on the coordinate plane. So if I have a 45-degree angle here, then if I make myself a right triangle here, and this is x and this is y, and I know this side right here is 1. In a 45-45-90 triangle, if I know the legs, then the hypotenuse is that leg times the square root of 2. So if my hypotenuse is 1, then Jade, what would I have to do to find x? Okay, so on the 45-45-90 triangle, we take our leg and we multiply it by square root of 2 to get the hypotenuse. So if we get, if we look at this circle here, or this triangle here, I know the hypotenuse is 1. What would I do to find the x? Okay, we won't multiply here because with the 45-45-90, we would take whatever the leg of the triangle is and multiply it by the square root of 2. For this one, we don't know the leg. We've got the hypotenuse, so we've got to go backwards from that. So instead of multiplying by square root of 2, what should we do? We'll divide. So we'll take 1 and we'll divide it by the square root of 2. And they don't like for us to leave it this way. So we'll rationalize. So that will give us the square root of 2 over 2. So our x is going to be square root of 2 over 2. And our y in a 45-45-90 triangle is isosceles. Both legs are the same. So we'll also have square root of 2 over 2 here as well. So on that unit circle, we can say that this angle right here, that's 45 degrees. And so we've got square root of 2 over 2 and square root of 2 over 2. There's that spot. Okay, questions? All right. The next thing that we need to do is the 60-degree angle. So if we made ourselves a right triangle here, we would still know that that hypotenuse would be 1 because it's also a radius. We'll label this side x and this side y. So for this one, that's the 30, 60, 90, where if we know that x, then we've got 2x as the hypotenuse and x squared of 3 is the longer side. So, Boone, what would we have to do to find that short leg, the x there? Divide by 2. So that x, we're going to get 1/2. So we'll have 1/2 as our x coordinate. And then, Boone, what would we do after that to find y? Okay, so we multiply by the square root of 3. 1/2 times the square root of 3. That's like square root of 3 over 1. So we end up with square root of 3. Come on. What's it doing? Square root of 3 over 2. And I don't know what in the world this is doing. Okay. Square root of 3 over 2. Okay? So you'll notice it's like the same triangle we had for the 30-degree angle. It's just been flipped where it's taller instead of wider. So we get the same coordinates. They're just switched. So here on that unit circle, we can have 1/2 square root of 3 over 2. And let's see, we're going to put a 60 degrees here. Okay, so I need you to know the first quadrant like the back of your hand. You need to know the first quadrant really, really, really well. So that if I ask you, well, we'll get to using the unit circle, but you need to be able to know this and picture it really, really, really easily. But as Elena was telling us earlier, if we know the first quadrant, we can figure out the rest of this pretty easily. Because if this point is square root of 3 over 2, 1/2, if I flip over to the left-hand side here in that second quadrant, then I'm still going to have the same coordinates, except for I'm going to have a sign change. Which sign is going to change? Right, negative square root of 3 over 2 and 1/2. And then the square root of 2 over 2. It's going to switch over here. Negative square root of 2 over 2 and positive square root of 2 over 2. And in this one, I'll have negative 1/2 square root of 3 over 2. Because if you remember for the quadrants over here, you should have a positive and a positive. Over here, if you're in the second quadrant, it's going to be a negative coordinate and a positive coordinate. Right here, you're going to have both negative, and right here, you'll have positive, negative. So, if we do I'm going to go ahead and do the fourth quadrant here. So, if this is square root of 3 over 2 and 1/2, if I reflect it over that x-axis, if I'm looking at this point at 30 degrees, and I'm going down here to this coordinate, they don't switch places. They'll just have, oh wait, let me do that. They'll just have, where is that? Okay. You'll just have square root of 3 over 2, and the y coordinate will become negative, so you have negative 1/2. And then so this one will be square root of 2 over 2 and negative square root of 2 over 2. And then this one will be 1/2 and negative square root of 3 over 2. So make sure you're filling in your unit circle as we get there. And then for the last quadrant, for that third quadrant, we could think of flipping either this point over the y-axis or this point over the x-axis. So we'll end up with negative square root of 3 over 2, negative 1/2. Here, we'll have negative square root of 2 over 2, negative square root of 2 over 2. Here, and negative 1/2, negative square root of 3 over 2 here. We're getting ready to do that. Yes, we're getting ready to do that. And I don't know if I do it the same as he does, but I'll show you the way I usually do it. All right. So that gives us all of our coordinates around the edge. We also need to know all of our angles. So this is what I do for this. Let's see. Let me get a highlighter here. All right. So this right here is 30 degrees. That angle right there is 30 degrees. So this angle would be 30 more, this would be 30 more, this would be 30 more, 30 more, 30 more. So if you're just going around that unit circle by increments of 30 degrees, you would be using all of those that I have highlighted in yellow. Alright, and notice the only things that I skip are the 45 degree angles there. So I just start counting 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210. I'm just adding 30 over and over and over again. 240, 270, 300, 330. And then back here, I could use 0 degrees or I could put 360 if I've gone all the way around. Okay. Then I can think of 45 degree angles. So 45 degree angles, let me get a different color for my highlighter here. Those are weird colors for highlighters. Green. Alright, so 45 degree angle is right here. That's a 45 degree angle. So if I go around the circle in those increments, there's 45, 45, 45, 45, 45, 45. So basically an eighth of the circle. So I know this is 45 degrees. I know if I add 45 more, I would get 90. If I add 45 more to 90, I'd get 135. If I add 45 more, I'd get 180. If I add 45 again, I'd get 225. Add 45 again, I'd get 270. Add 45 here, I would get 315. And then back to 360. Usually I can do better on the degrees, and I don't necessarily have to rely on that trick as much. What I find a little more difficult are my radians. So this first 30 degrees, does anybody remember what 30 degrees equals? We converted it yesterday. It is pi over 6. So 30 degrees is pi over 6. So I'm going to do this, and then I'm going to come back and reduce. So if this is pi over 6, this is 2 pi over 6. That'll reduce, but I'm going to come back and do it. This would be 3 pi over 6. This would be 4 pi over 6. This would be 5 pi over 6. This would be 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. And 11 pi over 6. Now, that's not how I want you to leave it, but it's pretty easy to picture it because you're just counting, going around, just adding pi over 6 over and over and over. Now, 2 pi over 6, that reduces. It'll reduce to pi over 3. So we want to fix that one, either cross it out or erase it and put pi over 6, pi over 3. 3 pi over 6, what would that reduce to? Pi over 2. So that would be pi over 2. Yes, 11 pi over 6. 4 pi over 6. We could divide both of those by 2. We'd get 2 pi over 3. 5 pi over 6 will not reduce. 6 pi over 6, those 6's are going to cancel and we'll just have pi. 7 pi over 6 will not reduce. 8 pi over 6, I could divide both of those by 2. I'll get 4 pi over 6 for that one. I'm sorry. Thank you. Mark that out. 4 pi over 3. Does that sound better? 9 pi over 6. Both of those are divisible by 3. So that's going to give me 3 pi over 2. And 10 pi over 6. That will reduce. That's going to be 5 pi over 3. Okay, and I'm just going to write these last ones in. You can do the same thing with the 45. This would be pi over 4, which would make this right here 2 pi over 4. That makes this 3 pi over 4. This would be 4 pi over 4, which also reduces to pi, which we already have there. This would be 5 pi over 4. 6 pi over 4, which reduces to 3 pi over 2. And then 7 pi over 4. Okay. Alright, so that is our unit circle filled in. We do not have time to go over how to use the unit circle. So you are in luck